Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will learn C programming language full course. Before we get started, I would like to take a quick confirmation from our viewers if the audio and video feed is clear from our end. If yes, kindly type in yes in the chat window. If there is anything that we could resolve from our end, kindly do let us know in the chat window. Alright, I see a lot of positive responses from our viewers. Great. So I think we are good to go. So, we will be learning the fundamentals of C programming language in today's tutorial. The topics covered in this session are Introduction to C, where we will have a quick briefing on originations of the mother of all programming languages. Next, we will get technical and proceed with C installation in your local systems. Once done with installation, we will dive into data types in C. Followed by data types in C, we will understand variables in C programming. Once done with two crucial concepts to get started with any programming languages, that are variables and data types, we are good to get started with our first program in C. Later, we will dig a little deeper and understand mathematical and logical concepts in C by going through operators in C. Followed by that, we will proceed with the data structures, starting with pointers in C. Later, arrays, strings. Once done with data structures, we will learn control statements in C. Functions in C, structures, unions in C. And moving ahead, we will learn enumeration in C programming. Soon after that, we will take a quick introduction to the dynamic programming concepts in C, starting with the heap data structure, then dynamic memory allocation in C, and finally, we will look into file handling in C. Myself clear with the agenda and we are good to get started. Dennis Ritchie, a computer scientist, was able to identify the gaps and tap out the best features from both B and BCPL languages to invent a new hybrid. Hence, C was born in 1972 at Bell Laboratories. A remarkably simple and highly readable programming language resulted in groundbreaking advancements in the IT industry. It was when programmers started to reach the saturation point due to the outdated programming languages. Programmers often face troubles with B and BCPL, the most advanced languages. C served its purpose and successfully solved the redundant problems faced by the major part of traditional programming languages. Sooner, C started spreading its roots into various IT domains and sprouting with groundbreaking applications that included graphics, user interfaces, and fully functional operating systems. Great! We have a sound briefing on C and its caliber. Let us now understand what makes C so powerful, and would it be enough to drive you to choose it to start building your applications? Slowly, the widespread use of C started to take over the IT industry. Unraveling the potential of C, the designers began to discover new possibilities that led them to focus on the big picture, a complete operating system designed using C. That's when the early Windows and Unix operating systems came into existence. Unix was the first ever fully functional operating system to be completely designed, developed, and deployed using C. It is one of the most popular languages due to its reliability and machine independence. Also, it owns the caliber to develop and deploy powerful end-to-end application level programs. Google, Mozilla Firefox, and MySQL are the popular examples to name a few. Another key to its success is that it became a user-friendly and most recommended programming language. Even today, C helps beginners learn and understand computer logic and programming fundamentals. Now that we know how powerful C language is, let's move ahead and understand some of the critical and cutting-edge features of the C language responsible for C's high success. The designers at Bell Laboratories made sure that their programming language solved the existing issues with B and BCPL and the ones they had foreseen. The most prominent one is the complexity of a programming language. C was developed so that it incorporated built-in functions to simplify mathematical and logical implementations and set rules or procedures to use them. The approach made it simple, easy to understand, and implement while in a head-to-head comparison to its forerunners. It also gives C an added advantage of platform independence and portability. It combines the features of both high-level and low-level languages, resulting in the faster execution and smoother application development. Hence, C earned its patent as the first middle-level programming language. Next, the whole C program can be divided into individual and functional units. It means every individual function in the program acts as an independent unit to perform a specific task or an operation and is also capable of running separately. C language comes with built-in libraries and functions. This pre-written header file helps user borrow and run the mathematical and logical operations directly from the library, helping them write simple and complex programs easily and drastically minimizing the development time. Next, C follows the top-down approach to the software development. Instead of classes and objects, a C program is divided into accessible smaller units called functions. The extendable nature of C allows developers to add additional functions to the C library, and also it quickly adapts to all the new features. C language contains a wide range of built-in operators that are used for different scenarios such as arithmetic operator, relational operator, logical operator, bitwise operator, and many more. Lastly, C introduced several memory management functions within the standard library header file, and they take care of allocating, deallocating, and reallocating the memories in C. So I think you got a good understanding of all the features of C. Okay, so let us move on to the applications of the C language. Let us look at the first application. C language is used to design operating systems. As discussed earlier, Unix operating system was the first ever operating system designed entirely using the C language. Later, a wide range of Android and Microsoft Windows applications were designed using C. Next, C is one of the most popular languages and is widely used in designing and developing embedded systems for electronic gadgets. Also, the software burnt into the embedded systems is developed using C. Graphical user interfaces are becoming increasingly popular in recent days. Electronic equipment relies on a fully fledged user interfaces for a better user experience. C is one of the foundational languages to introduce a simplified and user-friendly graphical interface. The early interfaces incorporated a few visual and graphics to interact with electronic devices. Next, Google File System was developed using the C language as a storage platform for generating and processing large volumes of data. Next, we have Mozilla Firefox. Mozilla Firefox is one of the free and open source web browsers coded using early standard versions of C. C language is also widely used in designing compilers and interpreters. A compiler translates the code from human understandable format to bytecode. The popular database MySQL was also developed using C. The simplicity of C enables MySQL to perform data manipulation tasks with ease. Now that we have some idea about the applications of C language, let's have a look at some advantages and disadvantages. C programming language is simple, so it is easy to understand. Due to its open source nature, it is completely free, resulting in almost low or no cost. It has the fastest execution speed because the entire C program is translated at once, unlike the interpreter which translates line by line. C language is portable because the program written in one operating system can compile and run on another system with minimum compatibility issues. C library contains header files such as standard input-output function, standard utility function, string handling functions, etc. It combines the features of both high-level and low-level languages, resulting in the faster execution and development. So, it is often called a middle-level language. Let's now look at some of the disadvantages of C language. C is a procedural language. Naturally, the concepts of objects and classes is not present in C, which is the major disadvantage of the latest software development styles. It does not support classes and objects. and C programs are divided into small units called functions. C language can translate the entire code in one go. Still, it often fails to recognize the critical runtime issues in the compilation stage, which happens to be another potential disadvantage. And it does not have an exception handling features. Unlike the popular object-oriented programming languages like Java, Python, and few other languages, it lacks the features of try and catch, which is employed exclusively for exception handling. Again, the C language does not have the features of constructor and destructor. It may have memory management functions, but they must be employed manually. At the same time, object-oriented programming languages like Java and Python have automatic memory management functions to take care of unused memory. They are called garbage collectors. With that, let's get into the companies using C and hiring software developers with the knowledge of C programming. And I'm sure you all are aware of the companies. So now let's have a look at that. We have MasterCard, IBM, Flipkart, Dell, Twitter, GitHub, and Twitch. The average salary of the software developers in the United States of America is 97,763 US dollars per annum. In India, the average salary of the C developers is 5 lakhs per annum. Visual Studio Code is Microsoft's most popular development tool for Windows, and it is an open source code editor to run C programs. And it is also used in game development, web development, and many more. So without further ado, let's get started with the installation process. First, let us install MinGW, which compiles C program. To install, let's open Google and search for MinGW C compiler. And now click on the first link. And here we see the download button. So let's click on this. As you can see, your download will start shortly. And once installed, let's open and run it. In MinGW Installation Manager Setup tool, click on Install. And it's a default directory. So let's click on Continue. Here, as you can see, download is in progress. So let's wait for it. Once done, click on Continue. Now, in MinGW Installation Manager, let's install all these packages. To install, right-click on the package and mark for installation. Okay, let's do the same. Right-click on the package and mark for installation. And once we are done with marking all these packages, click on Installation here and click on Apply Changes. And now click on Apply. It will take some time to install, so let's wait for it to get installed. Okay, so once installed, click on Close. Let's go to the folder and select the MinGW path. Okay, so double click on MinGW and now open bin and select this path. Ctrl C. And now let's add it to the environment variable. At bottom, search for environment variable. In system properties, click on environment variables, and in system variables, select Path and click on Edit. And now in Edit Environment variable, click on New and paste the path here. Okay, now click OK, OK and OK. Now let's install VS Code. Let's search for Visual Studio Code. Let's click on the first link. Now click on Download for Windows. And it's getting downloaded. As you can see, thanks for downloading VS Code for Windows. Let's now open and click on Run. So here, select I accept the agreement and click Next. It's a default location, so click on Next. Click Next. And here, select Create a Desktop icon and then click on Next. Okay, finally click on Install. It is getting installed and it will take some time to install. So once installed, click on the Finish button.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So let's open Visual Studio Code. As you can see, this is VS Code. And to compile the C program in VS Code, we need to install additional extensions like C++ and Code Runner. So, on the left hand side, let's click on the extension. And here, let's search for C++. So, this extension is from Microsoft, so click on Install. And it's installing. Okay, now let's search for Code Runner. Okay, now click on Install. Okay. So now let's do a simple C program. Click on New File. Now let's save the file. Okay, let's name the file with .c extension and click on Save. Okay, now let's include the header file. #include stdio.h. Now the main function. Void main. And inside main function, let's print hello world. Okay. So let's run the program now. To run the program, click on the play button here. As you can see, the program is running. So as you can see, save the program and then the output is printed here. Hello world. To run the programs, we will use VS Code editor. First, let's name the file with .c extension. Go to File, click on Save As, and name the file with .c extension. And to execute first C program hello world, let's include the header file. #include stdio.h. In C programming, #include is used to direct the compiler to load the header file in the program. stdio.h is a header file that stands for standard input-output. Various functions such as printf, scanf are defined in standard input-output header files. Next, void main. Main is a function from which every C program execution begins, and void specifies that a function does not return a value. Curly braces indicates the body of the main function, that is, the start and end of the statement. Inside the main function, let us print hello world. So for that, printf function is used to print the output. Printf hello world. And semicolon at the end of the statement indicates that the current statement is terminated. Now let's save the program, Ctrl+S, and let's run it. As you can see here, hello world is printed successfully. Let's try to execute one more program using arithmetic operators in C to get hands-on with it. So for that, let us declare and initialize variables inside the main function. That is int a is equal to 10, comma b is equal to 10, comma c. You can name the variables and assign values as per your needs. Now let's perform the addition operations on variables a and b and store the result in C. C is equal to a plus b. Using printf function, let's display the value for addition operation. Printf a plus b is equal to %d, comma c. Whatever is inside the double quotes will be displayed as an output. And %d is the format specifier used to display the integer value of variable type int. And \n is called an escape sequence which denotes the new line character. Now let's perform the other arithmetic operations one by one on the same variables a and b. C is equal to a minus b. And printf function to print the result of subtraction. Next, let's multiply using multiplication operator. C is equal to a into b. Printf function to display the result of multiplication. And then division. C is equal to a divided by b. Let's save the program, Ctrl+S, and run it. The results for arithmetic operations are printed successfully. As you can see here, a plus b, that is 10 plus 10 is equal to 20. Next, a minus b, that is 10 minus 10 is equal to 0. And then 10 into 10 is equal to 100. And a divided by b, that is 10 divided by 10 is equal to 1. Data types are used to notify the type of value assigned to a variable. 4 basic data types in C are int, float, char, and double. And the general syntax of data type is data type variable list and semicolon at the end. Great! Now that we know what are data types in C. Now let us understand the classification of data types. C data types are classified into three types. First up, we have basic data types, which are int, char, float, and double. Then we have derived data types, in which we have arrays and pointers. And finally, user-defined data types, which are enum, structure, and union. First, let us understand four basic data types in C. Variables of type int hold integer values ranging from -32768 to +32767, and it occupies 2 bytes of memory size. In this example, a, b, and sum are the variables of type int that hold integer values. Next, the variables of type char hold a single ASCII character that contains numbers from 1 to 9, small and capital letters A to Z, and some special characters enclosed within 2 single quotes, and occupies 1 byte of memory space. It ranges from -128 to +127. The float data type variables occupy 4 bytes of memory space that holds the value with decimal points, that is up to 6 decimal places. For example, pi and age are the variables of type float. They range from 3.4 into 10 to the power of -38 to +38. The variables of type double hold values with decimal points and occupy 8 bytes of memory space. In this example, a is the variable of type double ranging from 1.7 into 10 to the power of -308 to +308. Now let's have a look at the modifiers in C. Modifiers, are also known as qualifiers, are used to modify the basic data types in C. And the qualifiers are signed, unsigned, short, and long. Signed modifiers are used to hold both negative and positive numbers. At the same time, unsigned is used to store only negative numbers. So it's necessary to prefix the qualifier before the data types. And short requires memory space half the size of the basic data type. A long modifier is used to hold large numbers, and it doubles the size of the data type. The general syntax of handling modifier is modifier, basic data type, variable list, and semicolon. So in this particular example, unsigned is a modifier, int is a basic data type, and a is a variable. We cannot apply qualifiers to the float data type, but we can increase the size of the double data type by using a long qualifier. Also, we cannot apply qualifiers long and short on the char data type. Not just this, there are also a wide variety of data types available in C programming language. That comes in handy when you level up to the next stage with respect to your data. Let's look at the table that displays you the next range of data types and their format specifiers. You might want to take a screenshot for future reference. Okay, let's get started with char. For the data types char, signed char, and unsigned char, the size is 1 byte and its format specifier is %C. Next, int. The size is 2 bytes and its format specifier is %D. Unsigned int. The size is 2 bytes and its format specifier is %U. Next is long int. The size is 4 bytes and its format specifier is %LD. Unsigned long int, the size is 4 bytes and its format specifier is %LU. Next data type is float. The size is 4 bytes and its format specifier is %F. Double, the size is 8 bytes and its format specifier is %LF. Next we have long double. The size is 10 bytes and its format specifier is %LF. Now let's have a look at derived data types. As discussed earlier, array and pointers fall under derived data types. The array is a collection of elements of the same data type, and that can be of int, float, char, and double data types. As you all can see in this example, the array stores 6 elements of the same type int. Next, A pointer is a variable that holds the address of another variable declared under any basic data type. In this example, the pointer variable holds the address of normal variables in which the value 50 is stored. So I think you got a good understanding of derived data types. Okay, so let us now understand user-defined data types in C. Enum is an enumeration data type that holds constant integer values defined by the user. The syntax of enum data type is enum, enum name, and list of constant. In this particular example, enum is a keyword, furniture as enum name, and chair, table, book, rack would be constants. Next. The structure is a collection of elements having same or different data types. As you can see in this example, the elements declared as struct are of different data types. A variable A is of type int and B is of type float. And finally, we have a union data type that holds the different data type elements in the same memory location. In the following example, the union is a keyword, followed by that we have a union name and then the variable list. What are variables in C? A variable is a user-defined or a user-readable custom name assigned to a memory location. It is used to hold a value that can be modified and reused many times during the program execution. A variable name can be an alphabet or digits and can also start with an underscore. But a variable name cannot be a keyword. This might be ambiguous and need a little attention to detail. So basically, we can declare a car's name, a person's name, or any object's name as a variable. But a variable name cannot be a keyword. They are a set of words reserved for specific functionalities in C. These words cannot be used for any other user-related or custom functionalities. A few such keywords are int, float, for, while, etc. Now let's look at an example. So in this particular example, the user-defined variable A will store value at the address 2000. Upon the variable declaration, the memory allocation happens depending on the type of variable and its size. For example, if the data type is int, it creates the memory for the variable type int. The storage size of int is 2 bytes and 4 bytes for float. Let us now understand variable declaration in C with the help of syntax and examples. Syntax of variable declaration is data type, variable list, and semicolon at the end. Values assigned to variables can be of any data type like int, float, char, etc. So in this example, int is a data type, a, b, and sum are the variable list. And there are specific rules for naming a variable. Here are the valid variable names. In sum, float underscore ab, int b20. With these examples, we understood that a variable can have alphabets, start with an underscore character, and have digits. Now let's look at some invalid variable names. For example, int 38. A variable name cannot start with digits. In the next example, we cannot have white space within a variable name, and variable name cannot be a keyword. Now let's try to declare invalid variable names and run the program. Int 38 float x space y and int go2. So after declaring invalid variable names, we got an error for all the variable declaration stating that invalid suffix a on integer constant, expected comma semicolon before y, and expected identifier. Now that we know how to declare a C variable, let's move ahead and understand C variable initialization with the help of syntax and examples. Syntax of variable initialization is data type, variable 1 is equal to value 1, comma variable 2 is equal to value 2 and semicolon. So this is how we initialize the variable. For example, int a is equal to 10, comma b is equal to 20, comma sum. 10 is assigned to a variable a of type integer, value 20 is assigned to a variable b of the same type, and we have declared a variable sum. Okay, So let me now move on to the types of variables in C. There are 5 types of C variables. Let us understand one by one. Variables that are declared inside the functions are called local variables. In this example, we have declared variable a inside the function sum that holds the value 5. Let's try to execute a simple program using local variables in VS Code editor. Inside the function, let's declare and initialize the local variable. Int a is equal to 5. And then the printf function to print the value. Printf %d, comma a. Here, the value is printed successfully using local variable. Alright, let's move on to the next type of variable. Variables declared outside the functions are called global variables. Here is the example where float pi is equal to 3.14, a global variable defined outside the functions. Let's try to execute the program using global variables. Here, let's add the function circle and try to access the global variable in the function. Float pi is equal to 3.14, which is a global variable. Int circle, which is a function, and inside function let's declare variable r and area. Int r is equal to 5 double area. Formula for area of the circle, area is equal to pi into r. Return area. Inside void main, let's call the function circle. Printf %d, comma circle. As you can see, the circle's value for the area is printed successfully using global variable. Next, variables declared with a keyword static are static variables, whose lifetime is throughout the program runtime. As you can see in this example, static is a keyword used to declare a variable sum. Let's execute simple program using static keyword. Inside the function calculate, let's declare the variable sum with static keyword and initialize the value to 0. Static int sum is equal to 0. Sum plus plus to increment the value of sum by 1. Return sum. Inside the main function, let's call the function 2 times. Printf %d, comma calculate. For every function call, the value of the static variable will increment and print new value. That means the sum value was initially 0 and then incremented by 1 and printed value 1. Now the sum value is 1. The sum value will increment by 1 for the next function call and print the new value 2. Let's remove the keyword static and now run the program. As you can see the previous output with static keyword, for every function call, the value of the sum is incremented. Without static keyword, the value will be same for every function call. I hope you got the idea of using a static keyword, right? Next, variables declared with auto keywords are known as automatic variables. The variables declared inside the block of functions are automatic variables by default. In this example, int a is equal to 10 is an automatic variable by default. Now let's execute a program using the auto keyword. Int a is equal to 10. By default, this is an automatic variable. Let us also declare a variable with auto keyword. Auto int b is equal to 20. Printf %d comma a, and let's print the value for b. And here you get the output. Next, external variables share the variables among the multiple C files. To declare external variables, we use the keyword extern. Let's see how the extern keyword works. First, create a file with a .h extension, a header file, and define a variable with an extern keyword. Extern int x is equal to 10, comma y is equal to 20. In the file demo.c, let's try to access the external variables. So for that, let's include the header file demo.h. Hash include demo.h. Now inside the main function, let's declare the variable add. Int add. And now let's print the value for x and y using printf function. Printf %d comma x and let's print the value for y. And let's perform addition operation. For that, add is equal to x plus y. Printf %d comma add. As you can see, the output is printed successfully by using external variables.
An operator is used to operate on operands of any type. So in short, an operator is a symbol. In the example, a is equal to 2 plus 3, 2 and 3 are the operands and plus is the operator. So basically, the addition operation is performed on two operands. Now let's have a look at the types of operators in C. Based on the operands, the operators are classified into three types. First up, we have unary operators that are used to perform operation on a single operand. And the operators are unary minus, increment, decrement, and logical not. Next is binary operators that operates on two operands: arithmetic operator, relational operator, logical, bitwise, and assignment operator. And then the ternary operator, which is also known as the conditional operator. Great! Now that we know the types of operators in C. Now let's understand the unary operators that perform the operation on a single operand with their symbols and examples. Let's start with the unary minus operator represented by the minus symbol, which converts the positive value to a negative number. Consider the value y to be positive 2, and after performing the unary minus operation, the positive value 2 will be converted to negative 2. Next, increment and decrement operators are used to increase and decrease the value by 1 respectively. For example, plus plus y is pre-increment and y plus plus is post-increment. Similarly, we have pre-decrement and post-decrement. Next is logical NOT, that is used to complement the logical value. For example, consider the value for x and y to be 5 and 2, and the condition is 5 lesser or equal to 2, which is false. So the logical NOT operator will complement Boolean value to true in that case. I hope you got a clear understanding of unary operators. Next we have binary operators that operate on 2 operands. First we have arithmetic operators used to perform addition, subtraction, multiplication, division and modular operation. Let us know the performance of arithmetic operations with the help of a simple program. We have included all the arithmetic operators in this particular program. Now let's run the program and look at the result. Here, enter the value of a and b. As you can see, the result for all the operations is printed successfully. That is, 2 plus 3 is equal to 5, 2 minus 3 is equal to minus 1, 2 into 3 is equal to 6, and 2 divided by 3 is equal to 0. Relational operators are used for comparing 2 operands. First, we have the greater than operator that checks whether the operand 1 is greater than the operand 2. For example, x greater than y. Similarly, we have the other relational operators that are used to compare 2 operands, and they are less than or equal to, greater than or equal to, and not equal to. The following binary operator is the logical operator. In that we have the logical and, or, and not operators. So let us consider the example x greater than y, logical and x less than z. The logical AND operator returns the value true if both conditions are valid. Otherwise, it will return false. Next, the logical OR operator returns true if either condition is true. Else, it will return the value false. As discussed before, the logical NOT operator complements the value. Let's understand logical operators a little better by executing a program. As you all can see, in this particular program, we're going to perform logical operations. So let's run the program and see the output. So here it's asking press logical AND operator, press 2 to perform logical OR operation, and press 3 to perform NOT operation. So let us enter 1. So enter 3 numbers. Let me enter 2, 3 and 4. So here, since the condition is not satisfied, the return value is 0. Next, we have the bitwise operators in which we have bitwise AND, OR, XOR, complement, right shift and left shift. Let us understand the bitwise operators with the help of truth table. The bitwise AND operator compares the bits. If both the bits are high, that is 1, then the result would be high, else the result is low, which is 0. Next is the bitwise OR operator. If either of the bit is high, then the result is 1, else the result is 0. Next, we have an XOR operator in which the result is 0 when both the bits are zeros or ones, else the result is 1. Following we have assignment operators. You may understand better when you look at the example. The assignment operator is used to assign a value to a variable. As you can see in the example, x is equal to 5, the value 5 is given to the variable x. Next is to sum and assign. That is, x plus equal to 2 means the number 2 is added to the value of x. Next, subtract and assign. That means by subtracting the number 3 from the value of x. Then multiply and assign operator, which multiplies 2 with the value of x. The divide and assign operator is used to divide. For example, 2 is divided by the value of x. Similarly, the bitwise and assign operator ANDs the value of y with x. And then the bitwise OR and assign operator will OR the value of y with x. So I think you got a good understanding of all the binary operators. Okay. So let us now understand the ternary operator in C with the help of syntax and example. The syntax is expression 1 question mark, expression 2 colon, expression 3 and semicolon. For example, let us consider x is equal to 5 and y is equal to 2. Expression 1 must be the condition to be satisfied. So basically, if the condition is satisfied, it will execute the expression 2. Otherwise, it will execute expression 3. As you can see in this example, 5 less than 2. The condition is false, so that it will execute the expression 3, which means print the value 2. Now let's execute program using ternary operator. If the condition is satisfied, it's gonna print expression 2, else execute expression 3. So let's run it. Here, enter 2 numbers. So since the condition is not satisfied, the expression 3 is executed. I hope you got the idea of using the ternary operator, right? Now let's see how this special operator works. Some special operators in C programming are comma, address and size of. Now let's execute the program using special operators. So in this particular program, a comma operator is used while declaring variables. Next, the symbol ampersand represents the address operator to fetch the memory address of a variable, and the size of operator is used to know the size of data types occupied in the memory. Let's run it. Here, let's enter the value for A and B. So as you can see, the values are printed successfully. That is, the value of A is equal to 2, the value of B is equal to 3, and the size of int is equal to 4 bytes.
A pointer is a variable that holds the address of another variable to be executed, which can be of data type int, char, array, etc. Pointers are used so that we can easily access the memory location, and it reduces the storage space. Pointers also help us to increase the speed of a program's execution. Let's look at the example. Int asterisk p, where p is a pointer variable holding address of another variable of type integer. Similarly, a pointer variable can hold the address of a variable type char, float, array, etc. Now let's look at the pointer declaration. We have data type followed by asterisk symbol and name of a pointer variable. To assign a variable to a pointer, we use ampersand symbol. So for example, let's declare a variable of type int. After that, let's declare a pointer variable that is p. And then a variable a is assigned to a pointer variable p. So this means that a pointer is holding the address of a variable type int. Now let's look at the diagram and understand how pointers work in C language. So basically, when we declare a variable, memory is allocated and the value of a variable is stored in that memory at some address. So in this example, let's consider the address to be 2000. Similarly, when a pointer is declared, memory space is allocated at address 1000 and the value stored in that memory is the address of a variable a. Now let's execute a program using pointers. So in this particular program, we have assigned a variable a to a pointer variable p. So now p is holding the address of a, and we are trying to print the address of pointer variable p and the address of a variable a. Let's run it. As you can see the output, the pointer variable p holding the address of a variable a is similar to the address of a variable a holding a value 5. Alright. Up next we have a C pointer to an array. An array is a collection of homogeneous elements having same name and type.
C uses a pointer to an array to reduce the memory space of the program code. In a pointer to an array, the address of the first element of an array is assigned to the pointer variable. Let's consider the below example, where we have declared and initialized the array of elements, and then the first element of an array is assigned to the pointer variable p. Once the base address is assigned, the other elements of an array can be easily accessible. Suppose the array elements are 5, 10, 15, 20 and 25, and they are stored adjacent in the memory. Then, the memory space is allocated to the pointer variable at some address and it holds the address of the first element. Then, by incrementing the pointer variable by 1, the address of the next element of an array will be stored in the pointer p. Considering the below example, so once the pointer is incremented by 1, the address 1001 will be stored in the pointer p. Now let's look at the example program using a pointer to array.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
As you can see from this program, we will fetch the address of an array element. So for that, we have assigned a variable a to the pointer p, and with the help of for loop, we can access the address of the next element by incrementing the pointer variable p. So now let's run the program and look at the output. As you can see, we got the address of all the elements in the array. Now that we know pointer to array in C language, let's move ahead and understand pointer to function in C. As we all know, the function is a set of statements that perform a certain task to generate an output. Syntax to declare a pointer to a function is return type, pointer variable followed by list of arguments. To understand a little more about pointers to function, let's run a program. So in this particular program, we have a print function in which we are performing addition operation. And we are trying to get the address of a function by assigning the function name to the pointer variable. So this pointer to a function must accept two integers. Basically, it's holding the address of a function print. Now let's run it. So successfully we got an output using a pointer to a function. We got the value of a and b is 5 and 3. So the sum is 8. And the pointer variable p holding address of a function is 4199728, which is similar to the address of a function. Let's now look at the pointer to pointer. Pointer to pointer is nothing but a pointer variable holds the address of another pointer variable. For example, first we have declared the integer pointer variable p, and in the second declaration we have ptr which holds the address of another integer pointer variable p. Let's understand better by looking at the diagram. So here variable a is holding a value 5 at the address 2009, and the pointer variable p is holding the address of a variable a. Another pointer variable ptr is holding the address 2000 of the integer pointer variable p. Hope you got a clear idea of how pointer to pointer in C works.
An array is a homogeneous collection of elements of the same data type. That means similar type of elements are stored under one name called it as array name. And also the array of elements stored in a consecutive blocks of memory. Suppose you want to store 50 numbers. So for that, you must create 50 variables separately to hold the values. Instead, you can use arrays that contain more than one value under a single array name, which becomes easy to access the elements randomly and also avoids the memory overflow. Let's look at the diagram to see how the array elements are stored one after the other. Consider n elements to be stored in an array, and in that case, all elements are stored one after the other. Element 1 is the first element and the nth element is the last element of an array. In memory, whenever the consecutive free space is available, the memory is allocated as per the mentioned array size. Moving ahead, let's understand the array declaration in C. Array declaration is similar to the variable declaration, but in the array declaration, we mention the array size. Let's have a look at the syntax.
we have data type followed by array name and the array size. For example, data type could be any type like int, double, float, char, etc. In this example, the data type is int, an array name is ye, and the size of an array is 5. Once the array is declared, the memory is allocated as per the mentioned array size. In arrays, the index starts with 0 to n minus 1. So, to store 5 elements, the index starts from 0, then 1, 2, 3 and 4. Always the index will be 1 less than the mentioned array size. Next, we have array initialization in C. One way of initializing the array of elements is during the declaration. Let's look at the following syntax. First, data type followed by array name and size, and by using assignment operator equal to, list out the elements separated by the comma operator inside the curly brackets and semicolon at the end. For example, int ye of 5 is equal to the elements are 10, 15, 20, 25 and 30. As I said, the memory is allocated after the array declaration. And array elements are 10, 15, 20, 25 and 30 will be assigned starting from the index ye of 0, followed by 15 at the index ye of 1 and so on till the index ye of 4. Next up, we have how to access array elements in C. We can access the elements randomly by specifying the array index. The syntax to access the elements is mention the array name and the index of an element. Suppose you want to access element 15, and even though it is the second element, the index would be 1. So specify the array name and the index, that is ye of 1. Next, if you want to access the first element of an array, then the index would be 0. Similarly, to access the last element, we specify ye of 4. And to access the third element, give ye of 2, followed by ye of 3 to access the element 25. Now we know what an array in C is and its declaration, initialization and the way to access the array elements. Let's move ahead and understand the types of arrays in C. Arrays are classified into 3 types. First, we have one-dimensional array, next two-dimensional array, and finally multi-dimensional arrays. Let us go through them in detail. First, let's start with one-dimensional array. One-dimensional arrays are also linear arrays that accept one subscript to mention the size of an array. Look at the given representation of one-dimensional array. The elements are stored consecutively in the memory, and we have already discussed the array declaration. However, let us go through the syntax once again. We have a data type, array name and size. For example, int as a data type, ye as an array name, and the size is 15. Now let us try to execute a simple program to understand the one-dimensional array, and let's see how to access and change the array elements. Using one-dimensional array, we're going to print the array elements. And for that, we have declared the array name ye, and we have mentioned the array size 4, and we have also initialized the array elements, and they are 5, 10, 15 and 20. And using the for loop, I is equal to 0 till I less than 4. That means the index less than 4, it's gonna print all the elements. So now let's run the program. And here is the output. The array elements are 5, 10, 15 and 20. Next, let's try to access the array element. So suppose you want to access the second element of an array. So you can mention the array index using the printf function. So for the second element, the index would be 1. So let's run it. And here we got the second element, that is 10. So suppose you want to change the array elements. Like for example, you want first element to be 2 and not 5. So for that, mention the array name A and the index 0 and equal to the new element, that is 2. So let's print all the elements and check whether the element is changed or not. So save the program and run. So as you can see, the element is changed from 5 to 2. So now the elements are 2, 10, 15 and 20.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Next, we have two-dimensional arrays. A 2D array is similar to a one-dimensional array, but it accepts two subscripts. In 2D array, the data is stored in rows and columns. So using a 2D array, we can perform arithmetic operations like addition, subtraction, multiplication, etc. Now let's look at the given representation of a two-dimensional array. The index of the 2D array starts with 0, 0, then 0, 1, 0, 2, and followed by the next row 1, 0, 1, 1, and 1, 2. Let's have a look at the syntax to understand it in a better way. We have a data type, array name followed by two subscripts. The first subscript describes the number of rows and the second subscript describes the number of columns present. For example, if we have 2 rows and 3 columns, the index would be 0, 0, 0, 1, 0, 2 and 1, 0, 1, 1 and 1, 2. This indicates the first element is at the index 0th row, 0th column and the second element at 0th row, 1st column and so on. Now let's execute a program using 2D array by taking inputs from the user. So using a for loop, variables I and j are used to take the inputs of rows and columns. Followed by that, we are going to represent the elements in a matrix format. So first, I is equal to 0, that is I is initialized to 0 and checks I less than 2. And if the condition is satisfied, the control comes to the inner for loop and the j is equal to 0 and checks whether j is less than 3. And if the condition is satisfied, it will print the first element, a of ij. And again the control goes back to the inner for loop and increment the column by 1, that is j by 1. And now I value is same, that is 0 and j is incremented by 1 and it prints the second element of the matrix, that is the first row and second column element. And this process will continue till j less than 3 condition is invalid. Again the control goes back to the outer for loop and increment the I value by 1. And prints the second row first column element and this process repeats, it reaches the second row third column. Now let's run and see the output. So enter the random elements. Okay. And here we got the output. The elements are represented in a matrix format. Now let's perform the addition operation on the two matrices. We have matrix A and B of the size 2 into 3 and the elements of matrix A is 1, 2, 3, 4, 5 and 6 and the elements of matrix B is 6, 2, 3, 4, 5 and 1. So these elements are added up and stored it in the matrix C. So for that we have a statement C of ij is equal to A of ij plus B of ij. So that means the element of a matrix A is added with the elements of matrix B and store it in the matrix C. So the process happens, the first element of the matrix A is added with the first element of matrix B. And this will repeat till it reaches the second row, third column. So now let's run it. And here we got the output. So the element 1 plus 6 is added, that is 7. and stored in the matrix C. Similarly, 2 plus 2, 4, 3 plus 3, 6, and 4 plus 4 is added and the value is 8, 5 plus 5, 10, 6 plus 1, 7. Up next we have a 3-dimensional array. A 3D array is a multi-dimensional array that accepts 3 subscripts, which is represented by the block size, row size, and column size. The example for 3D array could be a cube, and the syntax is data type, array name followed by 3 subscripts. The first subscript represents the number of blocks, and the second one is the number of rows, and the third subscript represents the number of columns. For example, int data type, array name as A, block size 2, row size 3, and the column size is 4. So now let's execute a program to understand the working of 3D array. So we are going to execute a program using 3D array, and for that we have array name A, and we have the variables I, j, and k. So I represents the number of block and the size we have given is 2, j the number of rows and the size is 3, and k for the number of columns and the size is 3. So first it will take the inputs from the user and then print the output. The working is similar to 2D array. The only difference is that when I is equal to 0, it prints the first block of elements, and when I is equal to 1, it prints the second block of elements. And here the working is similar to the 2D array. So let's run it. So let's enter the random numbers. And here we got the output. So the first block of elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. And the second block of elements are 1, 2, 3, 4, 5, 6, and 7, 8, 1. A string is a sequence of characters represented within double quotes. String examples are as given below. Every time we initialize a string, it must be within double quotes. So for example, if a string is Simplilearn, then it must be within double quotes. Only then it will be considered a string. Strings are not just alphabets, but even if numbers or white space characters are enclosed within double quotes, even that is considered a string. Now let's look at the syntax to declare a string. We have the data type followed by string name and the size. Always a string must be declared of data type character. For example, we have char as data type, string name as str, it can be any name and followed by the size of a string. If the string size is 5, the last character would be a null character represented as a terminating character in the C programming language. Now that we know how to declare a string in C, moving ahead, let us understand string initialization. First, let's see the ways to initialize a string. We can initialize a string within double quotes by mentioning the string size. And another way is that it can be initialized without mentioning a string size in the subscript. And it can also be initialized inside the curly bracket character by character separated with the comma operator. Just by initializing character by character, the compiler will identify the number of characters in a string. Then it will store character in the memory and the terminating character, the null character. Look at the diagram below and understand how a string is stored in memory. First, memory is allocated at some address that holds the string A, B, C, D and null character at the end. And then the index starts from 0 to n-1. So in this example, the string elements are 5 and the index will start from 0 to 4. I hope it's clear. Okay, so let us move on to the operations on strings. We all know that we have many C programming language operations. Similarly, we can perform different operations on string. And a few such operations are finding the length of the string, concatenating two strings, copying a string to another string, and finally comparing two strings. So for all these operations, we have functions associated with it. We use string handling functions defined in the header file string.h to perform such operations in C language. A function like strlen is to find the length of a string. It will count the number of characters in a string and prints the output. Then, strcat is used to concat two strings, which means adding up two strings. Suppose our first string is simply and the second string is learn, then it will add both the strings and give us the output as a single string called Simplilearn. The following function is strcpy to copy a string to another, and finally strcmp to compare two strings. Now that we have some idea about the strings handling functions in C language, let's look at the functions to read and write a string. First, let's understand the functions of reading a string. Using scanf, getChar and gets, we can take string input. Scanf is used to read string and %s is the format specification. So when we use %s format specification to read a string from the terminal, then ampersand is not required. Next, the getChar function reads a single character by character from the terminal. Once the whole string is read, it is stored as an array in the memory. Following, we have the gets function defined in the stdio.h header file that reads character until it finds the new line character and add a null character to the string. Up next, we have functions of writing a string. And the functions are printf, putchar and puts. Printf function is used to print the string on the console. We use the %s format specification to print the string on the console. Next, putchar is used to print a single character. So using a loop, we can use putchar repeatedly in our programs and print all the string characters. Finally, we have puts function, from which the whole string is printed, which is defined in the header file stdio.h. Let's run a simple program to understand strings in a better way.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
As you all can see the program, we are trying to print the string called Simplilearn using printf function. So let's give string size less than a string. So let's give 5 and see the output. So here we got an warning saying that string for array of char is too long. That means it just prints the starting 5 characters of a string, SIMPL. So this is the starting 5 characters of a string called Simplilearn. Now let's remove the size and run the program. So as you can see, the whole string is printed. That means the compiler will identify the number of characters in a string and prints the output. In our next program, let's perform an operation using the string functions. So in this program, we are using puts and printf function to print the output. Then we have initialized two strings, and the first string is simply and second string is learn. In order to add both the strings, we are using strcat function. Now let's run the program and look at the output. As you can see, strings are concatenated successfully. So this was our first string called simply and second string learn. And both the strings are added up and given a single string called Simplilearn.
Control statements in C help the computer execute a certain logical statements and decide whether to enable the control of the flow through a certain set of statements or not. Also, it is used to direct the execution of statements under certain conditions. Let us consider an example of a stationery shop. When a girl wants to buy a ball pen, she says to the shopkeeper that she has the condition to purchase a pen of either of two colors, which are black or blue. So the shopkeeper first searched for the black color pen, keeping the condition in his mind. If the black color pen is not available in the shop, then the shopkeeper will search blue color pen. And if the condition is satisfied, the girl will buy the pen. Else, she will not buy it. Similarly, the computer executes these statements when the given condition is satisfied. Great. Now that we know what are control statements in C. Now let us understand the classification of control statements in C. First up, we have decision-making control statements. Then we have conditional statements. And finally, go-to statements and loop control statements. First, let us understand all the decision-making control statements in depth. Decision-making control statements are simple if-else statements, nested if-else statements, and else-if ladder. Let us go through them in detail. Now let's have a look at simple if statements. When you look at the flowchart, it is very clear that it first evaluates the if condition. And if the condition is true, the statements under if will be executed. Else, other statement outside the if will be executed. And the syntax of simple if is if condition followed by statement inside the curly brackets. Now let's execute the simple program using if statements.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this particular program based on simple if statement, it asks user to enter value for A and B. And it checks the condition A greater than B. And if A is greater than B, it prints the statement A is greater than B. In case A is not greater than B, it will not print anything. Now let's run it. Enter the numbers for A and B. Let's enter 10 and 5. And the output is 10 is greater than 5. Next, if-else statements. In this, it evaluates the condition, and if the condition is true, the statements under if will be executed. Otherwise, the statements under else will be executed and followed by other statements. Syntax of if-else statement is if condition statement 1, else statement 2. Let's understand the if-else statement with the help of an example program. This particular program is based on if-else statement. As I discussed before, it checks the if condition. And if the condition is satisfied, it will print the statement under if block. Otherwise, it will print the statements under else block. Let's run it. Enter the numbers for A and B. So, as you all can see the output, the value of A is not greater than B. That's why the statement under else block is executed. Next we have nested if-else statement. The nested if-else statements consist of another if or else. Let us understand nested if-else statements with the help of syntax. These consist of another if-else statement inside the outer if block and another if-else inside the outer else block. Let's understand by an example. This program is based on nested if-else. This is an outer if block and it consists of another if and else. It first checks the condition of outer if, and if the condition is not satisfied, then it checks the inner if condition. Even if that condition is not satisfied, it executes the statement under else block. In case even that condition is not satisfied, it comes outside the outer if block and execute the statements under outer ifs else block. Let's run it. Enter the numbers for A and B. 10 and 10. As you can see, the value of A and B are same. It has print the statement under outer else block. Now let's enter different values for A and B and check the output. So, since A is not equal to B and A is greater than B, the output is printed successfully. Next, else if ladder. Else if ladder statements contain multiple else if. When either of the condition is true, the statements under that particular if will be executed.
Otherwise, the statements under the else block will be executed. The syntax is if condition and followed by multiple else if. So now let's execute the program using an else if ladder. Enter the number for y. Let's enter 10. So it checks the condition y not equal to 10. Since the condition is not satisfied, it checks the next if condition. Since a is not greater than 15, it checks another if condition. And the condition a less than 20 is satisfied. And the output is 10 is less than 20. Now let's have a look at the control statements in C. As per the value of switch expression, the switch statement will allow multi-way branching. Depending on the expression, the control is transferred to that particular case label and execute the statements under it. If none of the cases are matched with the switch expression, then the default statement is executed. Syntax of switch statement is switch expression and inside the curly brackets multiple case labels and at the end default statement. Let's execute program based on switch statement. So in this particular program, if the expression of switch matches with any of the case label, then it will execute the statements under it. Now let's run the program. Enter value of n. Let's enter 4 and the output is value is invalid. It's because since the value of n is not matched with any of the case label, it has printed the default statement. Now let's have a look at goto statements. Goto statements are used to transfer the flow of control in a program. Goto statement is also known as jump control statements because it is used to jump to the specified part of the program. The syntax is goto, label name and semicolon. Label in goto statement is a name used to direct the branch to a specified point in the program. In the example, label name is odd. Next, we have loop control statements in C. In loop control statements, we have for loop, while loop and do while loop. Let us go through them in detail. For loop is also known as pretest loop. From the following syntax, expression 1 is an initialization, expression 2 is the conditional expression, and expression 3 is an updation. The variables can be initialized in the for loop statement itself. You might get a clear idea of using for loop when you look at the flowchart. In the for loop, expression 1 is used to initialize the variable, expression 2 is evaluated, and if the condition is true, then the body of for loop will be executed. And then the statements under expression 3 will be executed. This process is repeated as long as the for loop condition is true. Once the condition is false, control will return to the statements following the for loop and execute those statements. Let's see the example. In the for loop, the variable I is initialized to 0 and expression 2 is the condition, that is I less than n, and then the updation. Let's run it. As you can see the output, the value of I is printed until the condition is false. Up next we have a while loop. A while loop is also known as an entry loop because in a while loop the condition is tested first, then the statements under body of the while loop will be executed. If the while loop condition is false for the first time itself, then the statements under the while loop will not be executed even once. Let's have a look at the syntax of a while loop. While, condition, and inside the curly brackets we have statements. Let's execute the program using while loop. So here it first checks the while condition and then prints the statement. Let's run it. Enter the number for A. Let's enter 5. So since the condition is satisfied, it has executed statements under the while loop. Now let us try to enter different value for A. Let's enter 20. Since the condition is not satisfied, that is 20 is not less than or equal to 10, It has not executed statements even once. Next, the do-while loop. Do-while is also known as an exit loop because in the do-while loop, the statements will be executed first and then the condition is checked. If the condition of the while loop is true, then the body of the loop will be executed again and again until the condition is false. Once the condition is false, the control will transfer outside the do-while loop and execute statements followed soon after the do-while loop. The syntax is do and statement inside the curly brackets, then while condition. As you can see, this particular example is based on a do-while loop. It prints the statement first and then checks the while condition. So it prints the value of I until the condition is false. As you all can see the output, until the value of A is less than or equal to 5, the values are printed successfully. A function is a set of statements that perform a certain task to generate an output. We use functions to avoid the repetition of code in C programs. Functions can be called n number of times, and C allows multiple functions in a program. Now let's look at the structure of a function. In a function header, we have return type, function name, and a list of arguments, and the body of a function inside the curly brackets. Now let's have a look at the function definition in C. In the given below function definition example, we have int as a data type, product as a function name, followed by parameters a and b. Next, the body of a function consists set of statements to perform certain operation. So in this particular example, we're going to perform a product of two numbers. Up next, we have function declaration in C. A function declaration is also known as a function prototype in C. There are some important things to know about function declaration. And the first thing is that the function prototype must be placed before the main function. And if the function definition is placed before the main function, then the function prototype is unnecessary in the program. Next, function declaration may or may not contain parameters. Rather, it may have only data types of variables. Then, the function header must match the function declaration. Syntax of a function declaration is return type, function name, and parameter list. For example, int, product, and data types. If required, we can also specify variables along with the data type like int a, int b. Now that we know function definition and declaration in C language, let's move ahead and understand the types of functions in C. C has two types of functions, and they are library functions and user-defined functions. Library functions are built-in functions, or we can also say predefined functions in the header file. For example, functions like square root, string length, printf, scanf, etc. are predefined functions in C. To use library functions in the C program, we include a header file corresponding to that function. Functions that the user defines are called user-defined functions. Let's consider the below given example. We have three important features: function prototype, function call, and function definition. A function prototype is declared before the main function. Next, calling a function is done inside the main function. And then comes the function definition, in which we have a set of statements to be executed. Let's now look at some different categories of functions in C. First, functions with no argument and no returning value. Next, function with arguments but no returning value. Then, functions with no argument and returning value. And last, functions with arguments and returning value. Let us understand them with the help of our programs.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this program is function with no argument and no return value. As you can see, we have declared function prototype, function call, and function definition. in which we have function with no argument and no return value. And we're going to perform multiplication operation using user-defined function. Now let's run the program. According to the values of a variable 5 and 10, we got an output 5 into 10 is equal to 50. Now let's run the program using a function with arguments and no return value. And let's perform the same operation, that is multiplication. As you can see, product of two numbers is equal to 50 and we got an output. Next program is using a function with no argument and with return value. To get a return value, we have a data type int. Let's run it. As you all can see, we got an output. Product of two numbers is equal to 50. Last program to execute is function with arguments and return value. Let's run it. So the output is product of two numbers is equal to 50.
As we all know, array is a collection of elements of the same data type. Similarly, a structure is a collection of elements with the same or different data types. For example, unlike an array, a structure can have members of different data types like int, float, char, etc. Now let's have a look at structure declaration in C. We use the struct keyword before the tag name to define a structure. Tag name is nothing but a structure name. Whatever is declared inside the struct curly brackets are members of the structure. Once the members are declared, the variable has to be created to access the members of the structure. Now let's see the example. We have struct keyword followed by student as a tag name, then a list of structure members. And they are name of type char, roll number and age of type int, and s1 as a structure variable. We can have a list of structure variables. Another way of structure declaration is we can declare structure variable outside the curly brackets by using struct keyword followed by a tag name and then declare variable list. For example, struct keyword, then student tag name and s1 as a variable name. In structures in C programming, we cannot assign values during the definition of a structure. It indicates the wrong way to the declaration. So now, let us try to understand the right way of assigning values to the structure members in C. To assign values to all the members of a structure and access, we use dot operator, also known as a period operator. Look at the syntax below to clearly understand how we access and assign the structure members. First, the structure variables followed by the dot operator and structure members. For example, s1 dot roll number is equal to 34, s1 dot age is equal to 18, and we make use of the string function strcpy to copy the name. Next, we have structure initialization in C. We can also initialize the structure variable. And to initialize, we can directly assign values of all the structure members inside the curly brackets with an assignment operator. For example, struct student s1 is equal to, inside the curly brackets, enter the values separated by comma operator. In this particular example, name is John, the roll number is 22 and the age is 18. Now that we know how to declare and initialize structure variables in C, let's see how the structure elements are stored in the memory. As we know, char takes 1 byte of memory space. So, according to the size of the string, the characters will occupy in the memory. In structures, the memory is created once the structure variable is declared. As per this example, s1.name is a string, so that memory will be allocated and its base address will be obtained. For the s1 variable, the total memory allocated is 8 bytes, that is 5 bytes for s1.name, 2 bytes for s1.roll number and 2 bytes for s1.age. So I think you got a good understanding of how memory is allocated for the structure elements. Okay, so let us move on to the structure within structure in C. When a structure contains another structure as a member, it is known as a nested structure or structure within a structure. For example, let's consider a structure named student and another structure name as a date. In this example, a structured date acts as a member. So, a structured date has its own members and they are date, month and year of type int. And structure variable for date is DOJ. And the structure variable is initialized for both the members of the structure, that is name, admission number, age, date, month and year. Now let's execute a simple structure program.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
As you can see, in this particular program using the structure, we have initialized the variables and trying to print the values. And by using the dot operator, we are accessing the members of a structure. So now let's run it. And here we got an output, name, roll number and age of a student structure. In our next program using structure, we are using another way to declare variable and initialize the structure members. As you can see, we have declared variable outside the structure curly bracket. And inside the main function, we have initialized the structure members. So now let's run the program. So here we got the same output.
Union is a special data type that holds elements of different data types at the same memory location. The concept of structure and unions are the same. However, the only difference is in terms of storage space and the keyword. So, for union declaration, we use the keyword union. Now let's have a look at a union definition in C. The union definition starts with the keyword union and is followed by tag name or union name. Then a list of union members inside the curly brackets and finally a union variable declaration. For example, the definition begins with the keyword union, then student as a tag name. And the union members are name of type char and age of type int, followed by S1 as a union variable name. Now we know how to declare members of a union. Yet, the memory is not allocated to these union members. Moving ahead, let's look at the creation of a union variable. Similar to the concept of structures in C, even in union, memory is allocated once the variable is created. And the union variables are created to access and assign the values of a union members in C. The syntax to declare union variable is as given below. It starts with the keyword union, followed by tag name, then a list of union variables. For example, the keyword union, then tag name student, followed by the variable S1. Now, let's consider the below given example and understand how the structures in C is different from the unions. As I discussed before, the only difference between structure and union is in terms of memory space. In structures, the memory is allocated separately for every single structure member. In a union, memory is allocated at the same location for all the members of a union. The highest memory space of a member is considered and memory is allocated. In this example, we have members' name and age as a type char and int respectively. So with this example, let's understand the difference between structure and union elements in the memory. Once the variable is created, the memory for the members are allocated. In that case, the memory will be allocated for s1.name and s1.age. As we know, the size of a char is 1 byte. So, according to the size of a name, 4 bytes of memory space will be allocated and 2 bytes for age. So, the total memory allocated is 14 bytes. In the case of union, the memory for the elements name and age will be allocated at the same location. So, in this example, the highest memory space of an element is considered. That is, the size of an element name is 12 bytes. Now let's look at how to access the members of a union. We use the period operator to assign values and access the union members. The syntax that we follow to access the union members are union variable dot union member. Through an example, let's see how to assign values. So,
We have S1 as a variable name followed by a dot operator. Then age is a union member, and with the help of the assignment operator, we assign a value. And to access the member, we have an example s1.age. Now let's execute a simple program. From this program, we are going to find the difference between structure and union in terms of size. We have same list of members in both structure and union. So we're going to find the size it's occupying in the memory. Now let's run it. As you can see, the name in union occupies largest memory. So the total size of union student is 12 and structure occupies this as 20. I hope it's clear. Enum is a user-defined data type consisting of an integral constant. In short, enum is a keyword that allows a user-defined data type consisting set of integral constants. The syntax is enum, enum name, and list of constants separated with the help of comma operator. Now let's see what is enum used for. So basically, enum is used to allocate a name to the integral constant. In the given below example, we have enum as a keyword, fruit as a user-defined data type, followed by enumerated constants, mango, apple, grapes, and banana inside the curly brackets. Since this list of enumeration constants comes under the category of fruits, we have fruits as a user-defined data type, which is possible with the help of the keyword enum. Alright. In C programming, the compiler assigns integer values to all the enumeration constants by default. And that begins from 0, 1, 2. Okay. So let us move on to the enum variable declaration. Here, let us consider another example where we have month as a user-defined data type and January, February, March, April, May, and June as constant. As discussed before, by default, the compiler will assign values to the constant. It is even possible for the user to assign new integer values to the list of constants. For example, the value 5 is given to the constant March and the value 9 is assigned to the constant June. Then the compiler will automatically assign values to the rest of the constants that are starting from Jan is equal to 0, then Feb is equal to 1, April to 6 because it considers the previous constant value plus 1, so that is 6, then May as 7, again last value that is 6 plus 1 is equal to 7. And then comes the variable declaration. So as given below, the variable m is declared of the type month, and this variable can have only one value from the listed enumeration constant. That is, multiple values for a single variable are not allowed. But we can also declare various variable declaration for listed constants. For example, m1, m2, m3, and so on. Next, we can assign enumeration constant to the variables like m1 is equal to March and m2 is equal to April and etc. So now, m1 and m2 will hold an integer value 5 and 6 respectively. I hope you got a clear understanding of the use of enum in C programming. Alright. Now let's execute a simple program using enum.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So in this particular example, we are trying to print the integer value of variable m and m1. We have already assigned value 9 to the constant April. So now let's see the output. As you can see the output, the value of m is 2. So it's a default value assigned by the compiler. And the value of m1 is 9, assigned by the user.
The first thing to know is what is a heap. Heap is a free pool or memory storage space to store data dynamically. In program memory, the memory is divided into code, data, stack, and heap. So, when program variables are allocated dynamically, it is stored in the heap memory storage. We quickly store the elements in a heap to access the maximum or minimum elements of the data structure. And in C programming, heap is a complete tree-based data structure following a specific order. A heap consists of a root node, parent node, and a child node. The way roots are necessary for a tree, similarly, a root node is very important in a heap. The element of a root node is always greater than or equal to the other tree nodes, or it can be smaller than or equal to its child node. Suppose we have an array of elements 7, 5, 6, 2 and 3, and the index starts from 0 up to 4. So with this, let's implement a tree-based data structure. As you can see, the highest element is our root node, followed by the children nodes. Node element 5 and 6 are the child nodes of node 7, whereas node 5 is a parent node of 2 and 3. And if it is required to insert a few more elements in a heap, it starts inserting from left to right. And let the root node index be 0 and goes up to the elements present in a heap. Now we know what a heap data structure is and why heap is used in C programming. Let's move ahead and understand the types of heap data structure in C. There are two types of heaps, max heap and min heap. In a max heap, the elements of the root node must be greater than or equal to the elements of its children's node. Now let's see its example. In this particular example, 7 is the largest element than other elements in the node. So when you see towards down the heap, parent node element is greater than its children node. For example, root node 7 is greater than 5 and 6, and 5 is greater than its children node 2 and 3. Min heap is just opposite of max heap. The root node element of a min heap is lesser than or equal to its children node. For example, 2 is lesser than all other nodes in a heap. The parent node 3 is lesser than its children node 6 and 7. So I think you understood max heap and min heap well. Okay. So let us move on to the max heap implementation. Here we have an example. The heap elements are 7, 2, 6, 5 and 3. Now look at the steps to implement a heap. Let the root node index be I, the current element, and set the current element I to be the largest. In this given example, a parent node of 5 and 3, which is 2, is lesser than its children node. So heapify the heap. The left child index is given in terms of 2i plus 1 and the right child index is 2i plus 2. By considering this example, the index of node 2 is 1. So by calculating the left child index 2i plus 1, whereas I is equal to 1. So 2 into 1 is equal to 2 plus 1 is equal to 3. Swap the element with the index node 3. That is, swap the elements 2 and 5. So now the parent node is greater than its children node. And finally, the tree is heapified. Now let's have a look at the heap insertion operation.
Let's insert one new element into the heap. For example, if the element is 7 to be inserted, then it will be inserted from left to right at the bottom of the heap. Since the parent node element is less than its child node, that is 6 is less than 7, so we must heapify. So the next step is to heapify the tree by swapping the elements. And finally, the element is added to the heap. Next is a heap deletion operation. Suppose we want to delete one element from the heap. So let's consider element 5 to be deleted, and to delete element 5, swap the element with the last node element 7. And finally, remove the last element from the heap. Now let's run the simple program using heap data structure. So in this program, we are going to insert and heapify the heap elements. To organize the data of a heap max, we have swap function, in which we are going to swap the elements between parent node and child node. Following, we have a heap function. It first checks whether the size is equal to 1. It means there is only one element in the heap. Else, it will set the current element I to be largest. As we discussed before, the left node index is given in terms of 2 into I plus 1 and right node is 2 into I plus 2. And if left node is less than the size of heap and greater than the largest, then it will set the left node to be largest. Similarly, we do for the right node. And then we have an insertion function to insert the elements in the heap. Using if condition, it will first check the size of heap. If it is 0, then array index of 0 will be the new element.
and then increase the size by 1. Else, array size is new element. So once we insert the element into the heap, we are calling a heap function to organize the data. That means to heapify. And once the data is heapified, we have a print function. It will print all the array elements. And then inside the main function, we are giving the values to insert the elements, and they are 10, 3, 4, 2 and 6. And finally, it will print the heapified max heap elements. So now let's run the program and see the output. As you can see, the heapified max heap elements are 10, 6, 4, 2 and 3. So now let's try to insert one more element and see the output. So let's insert the element 8. Save the program and run. And here we go. The element 8 is successfully inserted. In our next program, let's try to perform deletion operation. So let's try to delete one element from the heap. So for that, we have a deletion function. If number to be deleted is equal to the array of index, then swap the element with the last node. So calling the heap function to heapify the elements and display it. And inside the main function, we are going to mention the element to be deleted, that is 6. So now let's run it. As you can see, the element 6 is deleted successfully. And the elements after deleting are 10, 4, 8, 2 and 3. As we all know, in C programming, the memory is automatically allocated to all the program variables during compile time. So sometimes to reallocate the memory or to change the size of an array, we must allocate memory during runtime. And we have two ways to allocate memory. And they are static memory allocation and dynamic memory allocation. In static memory allocation, the memory is allocated during compile time and the fixed size of memory will be assigned to the variables. Moreover, there won't be any change in the memory size and location. And in the case of dynamic memory allocation, the memory is allocated during runtime. So now let us try to understand more about dynamic memory allocation. To manage the memory more efficiently, we use dynamic memory allocation. Unlike static allocation, the memory is allocated during runtime in dynamic memory allocation. And the allocated memory is not constant or fixed. We can allocate the memory blocks from the heap whenever required. When the memory block is no longer in use, we can also return the block of memory to the heap for reuse by another program. And in addition to this, we can also reallocate the block of memory space when required. To allocate memory dynamically, C provides a set of functions, and they are malloc, calloc, realloc, and free functions that are defined in the stdlib.h, that is standard library header file. Let's look at the syntax and examples of this function. First, when we use the malloc function, the continuous block of memory will be allocated and the pointer variable will hold the address of the first element. Now, let's look at the below given syntax. The malloc function takes one argument, memory size. For example, if we require 10 bytes of memory size, we can mention 10 or we can mention the size of int. The malloc function will first check whether the continuous memory is available on the heap. And if free memory is unavailable, the function will return a 0 or a null value. Else, it will allocate the memory as per the requested size if memory is available. And the pointer will point to the address of the first element in the block. Next, we have calloc function. The syntax is pointer variable is equal to calloc of number element comma memory size. For example, we have 10 as a number element and the element size is the size of int. Calloc function is similar to the malloc function, but in case of calloc function, multiple blocks of memory of the same size will be allocated, which holds 0 value by default and it takes 2 arguments. that is number element and element size. Up next, we have realloc function. First, let us look at the syntax. Pointer variable is equal to realloc pointer variable comma memory size. In realloc function, we pass pointer variable as an argument and the memory size. For example, realloc pointer variable ptr comma the size of int. So sometimes it becomes very difficult to change the array size when we have to store new values into the array or to copy into the larger size array. So in that case, we use realloc functions to change the array size without losing the data. In short, the realloc function will change the size of the previously allocated block of memory. I hope you got a good understanding of why we use realloc function. Moving ahead, we have free function. Syntax is simple. We pass pointer in free function, like for example, free ptr. The free function is used to deallocate the memory space occupied by the previously allocated by malloc, calloc or realloc functions. In order to use the memory more efficiently and to return back the memory to the heap once done, we use free function. Once we free the memory, other programs can use that block of memory if required. Now let's run simple program using this function. So in this particular example, we have included the standard library header file, that is stdlib.h, and then malloc function. And using if condition, we're going to check whether memory is available or not. And if memory is available, it's going to allocate the memory and print the value 10. And finally, we have used free function to deallocate the memory. So now let's run it. As you all can see, the value 10 is printed successfully. Now, using same program, let's use calloc function. So instead of malloc, let's give calloc. And since we have passed only one argument, that is size of int, let's execute the program and see what would be the error. As you can see the error, it says that too few arguments to function calloc. It means that the calloc function will take 2 arguments. So let's give the number element. So save the program and run it. And here we got the output. As we all know, to maintain or organize the data, we use files. To understand in a better way why file handling is used, let's consider an example of our program's input and output. So what happens is that we store value in the variables and that data will be stored for time being in RAM. The data will be lost whenever the program is terminated or when the system is switched off. So when we want our results to be stored permanently in the secondary device, we use file handling functions. This means that the data is stored in a file using a program known as file handling. The main objectives of the file handling are to create, read, write, and update the files. In file handling, a file pointer is used to fetch and access the file in the program to perform operations on it. In general, a file pointer is a variable used to reference the files in the program. In C programming, we declare variables to hold a value, right? For example, int a, b. This means the variable a and b hold a value of type integer. Similarly, in file handling in C, the declaration is file, asterisk, and followed by file pointer name. In the following declaration, file acts similar to data type, which means that the file pointer variable is of the type file. In file handling, every file is represented with a unique file pointer variable to access the file and perform certain operations. The general syntax to open a file is file, asterisk, and followed by the file pointer name. Then, to open a file, we use the function fopen and specify the file name and the mode, which will be assigned to the file pointer variable. Alright. Now, let's have a look at the file handling operations in C. To do any operations on the file, we first create a file and then perform operations. But if the file already exists, we open an existing file and perform the task. And once after the creation or opening a file, we read from a file or write to a file. Or if required, we perform both the operations. And the next operation we have is to move a file to the specified location. If required, we can move a file. Otherwise, the last operation is to close the file. So whenever we open a file, it's compulsory to close the file. Therefore, we have a set of functions to perform operations on the file. So now let's see what are those file handling functions are. We have so many functions to handle files in C, but in this session, we will understand a few basic and important functions. And the functions are given below. As discussed before, to perform any operation, the first thing is to open an existing file and then perform the task. So basically, fopen function is used to open an existing file. And if the file is not present in the system, it will return a null. The following function we have is fclose. Whenever we open a file and complete the operations on it, finally we must close a file. In addition to this, there is a limit to opening many files at a time. So the unnecessary files must be closed when the task is completed. Next, fprintf function is similar to printf function. As we all know, printf function is used to print the output, or we can say it is used to print the result on the console. Whereas fprintf function is used to write values in the specified file. Up next we have fscanf function, which is similar to scanf function. Again, we know that scanf function is used to take inputs from the user, whereas fscanf function is used to read data or information from the specified file. Next, we have fputs and fgets function, used to write and read strings from files respectively. Following we have fseek function. So whenever we want to write or read something on a specific part of the file, we need to set the pointer to that particular position. And to do this, we use fseek function. Then we have rewind function, that is used to set the current position to the start of the file. That means the pointer is set to the beginning of the file. And finally, we have remove function. Hence, the remove function is used to delete the file. So I think you got a good understanding of all the file handling functions of C. Okay. So let us move on to the file opening modes of C language. These opening modes specify on what basis the file is opened. For example, suppose you want to write something on the file. We open an existing file using fopen function and specify the mode either to read or write the file. And that is done using the following file opening modes. First, let's start with mode R. It is used to open existing text file to read only. And mode W creates and opens the file for writing. But if the file already exists, then it will overwrite its content. Next is EAT, which is used to append the data at the end of the existing file. Append is nothing but adding up the data for writing only. Then RT+, where R stands for reading and T stands for text file. So this mode opens the existing file to read and write. Next, the WT+. This mode creates and opens the file for reading and writing. But if the file exists, it will overwrite the content or empty the content of the existing file. And then EAP+ will append the data at the end of the existing file and open it for reading and writing. Following, we have RB, where B stands for binary files. So basically, it is used to open an existing binary file for reading only. WB, this mode is used to create and open an existing binary file for writing. EAB mode appends at the end of the existing binary file. Next, RB plus opens an existing binary file for reading and writing. WB plus creates and opens the binary file for reading and writing. And finally, we have EAB plus. This mode is used to append to the end of the existing binary file for reading and writing. So now, let's have a look at the declaration. Let's see how the functions and modes are used in file handling. For the file opening operation, we have the following declaration: file and followed by file pointer name. The pointer variable will contain the address of the file structure. So as discussed before, to perform any operation on the file, we must open a file. So for that, we have the fopen function assigned to a file pointer variable, specified with the file name and the mode. So in this example, the file is open to perform the write operation. The following declaration is based on a reading a file. Therefore, fscanf function is used to read from a file. We can also use the fgets function. Next, write a file. So first we open an existing file and specify the file name and the mode W, that is the write mode. The fprintf function is followed to write data on a specified file. Finally, after performing the operations on the file, we must close the file. And to close the file, we use fclose function. The function parameter is the pointer name. Now, let us understand this operation using a simple program.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this program, we're going to perform the write and read operation. So for that, let's first open a file named file1.c. And the next step is to write on the open file. And once we write the content into the open file, we're going to read from the file. And at last, we will close the file. So now let's run it. Enter the file content. Okay. And once you write the data into the file, the next step is to read data from the file. Reading content of the file. Hey guys, welcome you all to Simplilearn, and it's printed successfully. So now let's open the file and see if the data is written into the file. So this is the file and it's written successfully.
So with this, we have come to the end of this session on C tutorial for beginners. I hope this session was informative and interesting. If you have any queries regarding any of the topics covered in this session, or if you require the resources like PPT, code documents or anything, then please feel free to let us know in the comment section below. And our team of experts will be happier to resolve all your queries at the earliest. Until next time, thank you, stay safe and keep learning.